last but not least, we're more than happy to welcome the final speaker for the room 2. So the speaker will be Kathryn Hadley. Kathryn is director and digital forensic specialist at the SENS Institute, where she's been leading research team and co-authoring a SENS course on digital forensics fundamentals. Today, Kathryn will deep dive into a very new topic, actually, which is the Linux phones. So she will explain to us how we can get those phones and how we can configure those devices. So please note that this will be a pretty technical presentation, but Kathryn will try to make it as clear as possible. So if you have any question, as usual, you can ask it in the chat or Q&A, and we have some dedicated time at the end to respond to those questions. So Kathryn, just in time, the floor is yours then.
Awesome. Thank you very much. And thank you for having me here. I've been listening to some of the talks already in other rooms, bouncing between them. So yeah, there's some great stuff being talked about today. So yeah, thank you very much for hosting it and setting it up. Yeah, as Lucy mentioned, I am here to talk about the PinePhone. And what is the PinePhone, you may say? So yeah, it's the first Linux-based smartphone. So you've already got iPhones, which are based on iOS, all written by Apple, and you have Android devices, which different manufacturers, but are all based on the Android operating system. And Linux phones, or the PinePhone is the only one at the moment, is just another smartphone, but with a different operating system. So this is all Linux based, and it can be different flavors of Linux. There are a number of options available. So you can, at the moment, you can buy phones that have Manjaro Linux on them. However, you can change that if you want to be things like Fedora, Ubuntu Touch, Mobian. There's lots of options available if you want to change the version of Linux you're using, because they are all slightly different. If you've used Linux before, then you know there are variations on a theme, really, when it comes to Linux. The smartphones themselves, to show you what they look like, I have two models, so Blue Peter style. Here are two I prepared earlier. They come in nice shiny boxes. So I've purchased two, and they look like a typical smartphone, really. So this one is black. I think actually everything I could have bought was black. I don't think they have many options in colors. Luckily, black is my favorite smartphone color anyway. And yeah, you can see it looks like a standard smartphone, really. The key differences, so why do these exist? Partially to create a market for Linux smartphones. They don't exist, or they didn't exist before these devices. And in order to get people interested in this sort of thing and make it a thing, make it something that exists, they've created them to generate interest primarily in them, but also for development and playing around, because we love to do that with technology. So they are basically developer phones at the moment. They do have some bugs. So the first one I purchased, which is this one here, which I've just turned on, is a little bit buggy. So some of the applications don't work. The email application, for example, I loaded it up, it crashed a lot. However, most of it does work. So just be aware, there may be some bits of hardware that it doesn't recognize, and it can crash a bunch. This one is a slightly newer model, and it's much more stable. So they are improving as they go along, and they release more models. So as I say, still quite new. But the good thing about these, let me pull the back off this one. And the primary difference with these devices, if you can see, possibly a little bit blurred. However, up here, if I back off a little bit, you can see some switches. So each of those switches allows you to turn on or off Wi-Fi, Bluetooth, microphone, camera. In fact, rear and front camera are two different switches. So from a privacy perspective, these are actually really, really good, because normal smartphones, you can't turn off any of the hardware, let alone individually. And even now with iOS 15 coming out, even if the phone is turned off, then Bluetooth is still on and it's still actively looking for other devices to connect to in case you want to report it stolen and go looking for it. So big difference with these phones is that you can turn the hardware off and actually it is disabled from there. So yeah, it's going to be, I think, a much more interesting and useful thing moving forwards. Why am I looking at them? So as Lucy mentioned, I am an author and instructor with SANS. I do digital forensics as a day job, have done for the last 13 years. And from my perspective, a new device comes out, I want to know what it looks like from a forensic perspective, so that if I get one of these that appears on my desk as part of a case, I know what data is on it and how I can go and get that data in order to analyze it and solve my case, do my investigation. So I purchased 2 of these to do just that, to work out how do we acquire the data on this device? How do I get RAM? Can I get RAM from a device? I can't get RAM from an iPhone, for example. Can I get it from one of these? And then where is the data stored? What data is stored on these devices and how do we get hold of it? How do we understand it? How do we make sense of it in an investigation? So that was my remit, effectively, the scope of what I wanted to do. And that's what I've put together here. So hopefully I can share. Can I share my screen? Cool. Hopefully you can now see PinePhone Forensics. Amazing. So if I zoom into this, so this is a poster that I've put together. I figured it was easy to have all the data in one place rather than doing slides. So this will be available, so you can have a look at this in your own time. But first of all, basically, how do we get to the data? And with these devices, they have an SD card slot. So the easiest way, and actually the only way I've got to work so far, is to connect an SD card into the SD card slot, go into the device, turn the device on. The device is just running standard Linux, and actually it's kind of a desktop version of Linux. So that means lots of things don't render properly on the screen because it thinks it's a desktop. But the plus side is you have a command prompt. You have the terminal application like you would on any version of Linux. You can open that up. You can mount the SD card. So I've given you the commands here in order to do that. So I would run mount, which tells me what is already mounted. From there, I would look for what device is root. So I want to know what I need to acquire to get the data. So root is the root of the operating system. That's where all of the data on the phone is stored. So I need to know what is mounted as root, which will be /dev/something, to get hold of that data. Once I know what that is, and on my device, it happened to be /dev/mmcblk2p2, because why not? I don't know, but it happened to be that particular device. I can then mount the SD card. So to do that, I go into /dev again to look for which device is my SD card. Once I know what that is, I can then mount it. So I create a directory to mount that device into. I then do a mount command and I say mount this device under that new folder. And that just gives me access to all of those files in that block device that is the SD card. And once I know which device is the device itself, is the root of the phone, and once I know where my SD card is mounted, and I can see that particular mounted folder, I can then image it. And the simplest way of imaging anything in digital forensics is using something called the DD command. DD, nobody knows what it stands for. We call it disk destroyer because if you get it wrong, then you can wipe the data that you didn't mean to wipe. If you get things the wrong way around, it starts writing to your source instead of your destination. So make sure you get these the right way around. It has been done. We've all done it. We've all accidentally overwritten our forensic analysis machine by mistake instead of acquiring our evidence. So to do this, IF is the input file. That needs to be the whatever is mounted as the root of the phone itself. So I say in my case, that was mmcblk2. The output file is the destination you're writing to, which needs to be your SD card folder. So where we've mounted that SD card. I've mounted mine in this example to /mnt/SD card. And the file name I'm then giving it is mmcblk2.dd, because I know this is device mmcblk2, so I'm just naming it according to that. But you can call it whatever you want, as long as it makes sense to you. Leave that to run. It may take a little while. I think mine probably took a couple of minutes. Once it finishes, you will then get DD will end. You will get an output to say, I copied this many bytes, and you will get the prompt back again in terminal. Once you've done that, you can then unmount the SD card. So just sudo umount and then the SD card folder. You can then turn the device off and you can pull out the SD card and plug that into your analysis machine to then have a look at that image in the same way you would for any other image in digital forensics using digital forensic tools. So it's actually pretty straightforward to acquire these devices. It's not particularly what we call forensically sound. So normally, best case scenario is you are not modifying any of the data on the device. With any smartphone, it needs to be turned on in order to acquire the data. So any smartphone is going to be modified in some way when you do the acquisition. This is no different really, but you are adding a few commands into the bash history, the command history that is saved onto that particular device. So be aware of that. If you did do this in an investigation, you would need to write that down and be able to explain what you did. But it's not the end of the world, and it is a really easy way to get the data. So some good options there. In terms of RAM, as I mentioned, it's not really possible to get RAM on iOS devices. Android devices, not so easy either. However, on this device, actually pretty easy. It's the same as any other Linux device. Probably not a surprise, as I keep saying, it's just a Linux system. However, grabbing RAM from Linux is not as straightforward as something like Windows. For example, on Windows, you can just run an executable, something like Dumpit, one of my favorite tools, and that executable will just work. You run it, you say, yes, I want to acquire this, and you get a RAM dump. Super easy. On Linux systems, a little bit different. You have to build something called a kernel module. Once you have that kernel module, you can then run Lime to, insmod using Lime to get the copy of the RAM. So to do that, we have to first use Lime and build the kernel module, which ideally we wouldn't do on our evidence device if we have one. So go and buy an exact copy, if you can, of the device you want to get the RAM off, build that kernel module on a test device, and then copy it over on the SD card to your evidence item, and then you can run insmod to copy the RAM onto that SD card. So it's a bit of an involved process, but it is doable, which is a big step up from other smartphones and actually other mobile devices, because yeah, we can't do this on, well, it's really difficult to do this on lots of different mobile devices. So really good, it's possible, but you need to understand how to build kernel modules and using Lime and insmod. Instructions are there if you want to give this a go. I've given all of the commands on here, so yeah, crack on and see if it works for you. This did work on my system, and I did have a usable memory dump at the end of it. So this does work, it is possible, but give it a go and play around with it. Then in terms of what data is stored, this is a non-exhaustive list of what's actually on the system. So I kind of split it into two categories, because you have Linux artifacts, which are stored on all Linux systems, but you then also have mobile device related artifacts. So for example, normal Windows laptop, you wouldn't expect to have things like contacts, call logs, messages, all of those sorts of things, because they are phone related. So this does give you extra information above a standard Linux system. So kind of running down here, these are in alphabetical order. First of all, we have bash history. This is all of the commands that you type into that terminal application. Standard Linux artifact behaves in the same way, it's in the same location. So nothing different there to a standard Linux system, but really, really handy, because users of these systems might be running commands, and you might want to know what they've been doing. So in an investigation, this is where we'd find it, and yeah, it could be useful to show what the user has done on that system. Then you have the WTMP file. So on a typical Linux system, you will also have other similar UTMP files, which store things like user login events. And helpful on a standard Linux system. On this mobile device, however, out of the 3 that are typically available, only WTMP exists. And not all events were logged. So it only logged, I think, 2 out of the logins I did, and I probably did about 5 or 6. And the timestamps were set to 0 effectively. So I couldn't correlate that with when I actually did the activity. So in itself, not a very helpful log. However, maybe moving forward, this will become more useful. So worth noting, it exists on these devices, and maybe it will be properly populated in the future. We then have calendar entries, which this behaves like any calendar you would expect on a phone. It is stored in calendar files, so ICS files, and each file starts with begin vCalendar. Within there, you then have the events that are in that calendar. Each event starts begin vEvent and it ends end vEvent, and then you'll have the next event underneath. Text-based format, really easy to parse. And yeah, all of the data was stored in this particular file. Call logs then are specific to obviously a smartphone, so you won't get this on a standard Linux system. This is stored in a SQLite database. We like SQLite databases, really easy to parse. We have lots of tools for them. We understand them really well. So really helpful to have this. There is a calls table within this database that stores, believe it or not, all of the calls. This has a field called inbound. That is 0 if the call is outgoing, so your user makes a call, and it's 1 if the user receives a call. So again, easy to parse, and all of the data is there and helpful. Contacts, again, is a phone-related artifact stored in another SQLite database called contacts.db, and it stores your contacts in there. If the user has assigned a photograph to any of those contacts, that is stored in a separate location. So same folder, but in a subfolder called photos. And in there, you will get PNG files, so image files for those particular contacts. So you don't have to assign a photograph to a contact, but if you do, that's where it will be stored. And the name of that, the first part of the PNG name will be a unique identifier that you can then link back to the contacts database to work out which contact that actually applies to. So you can connect those two together quite easily, which is good because you need to be able to work out which contact that is. The device itself has a unique identifier that's stored in /etc/machine ID. Plain text file only contains the ID. So really simple. Any document that the user creates, there is a text editor on the device by default. However, this is one of those applications where it is configured for a desktop. It's configured for a laptop screen. So trying to use that on a mobile device is not particularly easy because the button you need to save that file, for example, is off the screen somewhere because it thinks the screen is bigger than it actually is. So one of the examples of bugs on this particular device, which makes it hard to use, so you may not get many documents stored at this point in time. But moving forwards, good to note where this data is stored, and it's just stored in documents. So really easy to find, and they're plain text files. It's not like Microsoft Office. It is just a plain text editor. So yeah, just plain text documents and all in one location. The default browser on mine was Firefox, and that is stored in a Firefox folder, and it contains all of the artifacts you would expect from Firefox. Firefox is pretty consistent across platforms. It has SQLite databases, things like places.sqlite store things like browser history, download data, cookies stores cookies. Form history is all of the text that you've entered into forms in websites. And all of this is stored in the same way as it would be on pretty much any other platform. We can parse this with all of the existing Firefox tools we have. So again, we understand all of this, really easy. Tools are available already. There's a list of installed applications in something called pacman.log. So on these devices, I didn't have apt on there, which I'm used to. If you operate Linux, I'm so used to typing in sudo apt-get to get an application and install it on the device. Not installed on these devices, you have to use something called pacman, which took a bit of getting used to for me. And it logs whenever you do a pacman install of an application, it logs it in pacman.log. However, if you've used Linux, you know that when you install an application, it comes back and says, here's a bunch of prerequisites you will need before I can install what you want me to install. So it could be other applications, it could be libraries, it could be anything that it needs in order to do what you've asked it to do and install that application. So therefore, this pacman.log, very, very noisy, extremely noisy, because you get all of those prerequisites installed, and it will say, I'm now installing this, I'm now installing this, I'm now installing this, before you get to what you've actually asked the device to install. So yes, it will include a list of installed applications. However, it will also include a bunch of other stuff it also needed in order to do that. So be aware, lots and lots of lines in there, and you may have to sift through for what's relevant. Then we have maps. So on this particular device, there was a map application, and that stores any destinations you've searched for, so search terms, in something called mapsplaces.json. JSON is plain text, so again, pretty easy to parse. And if you search through, it will say name equals and then whatever the user searched for. So actually quite straightforward to work out what the user's been doing with a map. You also get tiles. So when I searched for a destination, I then said, give me directions from where I am to that destination. What the Maps application then did was plot that route and divide the screenshots effectively of how to show me how to get there into squares, into tiles. Those tiles that were then shown to me in order to get to my destination were stored in a different folder. So they were stored in, for me, mapbox.streets.v11. And then I had a bunch of PNG image files that contained each of those tiles. And then it's a bit like a jigsaw. So you can kind of piece it back together, if you like jigsaw puzzles, to then actually see the route that it was displaying to me for that particular search. Really cool. However, there were multiple folders in there, so I didn't just have V11. V11 was the latest one that I had. I also had a V9 folder, which wasn't related to anything I did. It was pre-existing on the device. So be aware that you probably will have map tiles if the map application has been used, but potentially it doesn't all relate to user activity. There might be some existing data on there that is not relevant to your particular case. We then have operating system information. So this just tells me it's Manjaro and the version of Manjaro that is installed on this particular device, which is good when we start our report and we need to profile the device and write down things like operating system version, hostname, all of those sorts of things. This is where you would get that information. Any photographs taken with the camera are stored in pictures, the pictures folder. And every time you take a photograph, you get two files. So you will see duplication, you get a JPEG, and you get something called a DNG, which is a raw image. Not quite sure why it stores both, particularly as neither are great quality. I mean, it's not like using an SLR camera, but just be aware you will get two copies of every photograph taken with the camera, and they will be named according to the date and time they were taken. Depending, so that is taken from the device time, so be aware. If the device is set to 2 weeks in the future, that is the date and time you will get for these files. So take that into account, but otherwise it's quite a good indication of when that photograph was taken. You may get thumbnails for photos. However, I got one for about 5 photographs taken. I don't know why one gave me a thumbnail and the rest didn't. It wasn't consistent and I couldn't replicate that situation. So yeah, just be aware. You might get thumbnails, you might not, and no idea when that occurs and when it doesn't. But if you do, it's stored in the thumbnails folder. Again, recent activity. This is a Linux artifact called recentlyused.xbel, standard, I say artifact on Linux. Typically on a Linux system, I would expect this to be populated. It wasn't on this device. It gave me random things. So it would tell me one photograph that was taken. It would tell me one document that was created, but it didn't tell me if another photograph was taken or a different document was created, or I sent a message, or I added a contact. Like again, it was inconsistent. It was random. So good to show me some activity that had happened on that device. But if it's not in the log, don't assume it didn't happen, basically, because stuff was missed. SMS messages are stored in an XML file, which this was a bit of an odd thing. So it's stored in both SQLite in chattyhistory.db. The text application is called Chatty. Just that's where that comes from. But you also get this XML file. So the SQLite database, we understand SQLite, brilliant. You get a Chatty IM table, and that tells you a direction as well. So for some reason, in this case, it's -1 means it's an outgoing message. 1 means it's an incoming message. But a table you can see and understand, really simple. In addition to that, you get XML files. And so this, actually, let me deal with XML first. So XML is the contacts you have messaged just using SMS. So that will include the name of the person or organization, or the details, so telephone number or whatever it may be for your contact, and whether it is known or not, so whether that's in device contacts or whether it's just been typed in directly to SMS messages. Then you also get HTML files, which include the SMS messages as well. You'll get one HTML file per day, and within that will be all the SMS messages sent and received on that particular date and time. Bit of duplication, bit of a mishmash, to be honest. Not really seen this before. It's a bit unique to these systems, but be aware you've got 3 locations where SMS data is being recorded. Some of it's duplicated. The SQLite and HTML files contained exactly the same information, just in different formats. I don't know why it does that, but it is there twice. We then have the suspend log. I thought this would be incredibly useful, telling me when the device had been suspended. It wasn't. Again, inconsistent. Not all suspend events were logged. Task list included a list of tasks. So you can create a list of, like a shopping list, for example. You've got a list, you enter individual tasks in it, and you can kind of cross them off as you go along. Task list was contained in a plain text .source file in evolution-sources, and then the individual tasks that were in each list were stored in a completely different location, and this was another ICS file. So tasks.ics has, it's actually a vCalendar file, so it begins again with vCalendar. Underneath, you then have begin v to do and end v to do in chunks, in blocks. You can parse that out really easily. It's a plain text file, and then you can bolt those 2 things together. So 2 different formats, 2 different locations. You have to kind of manually connect them to work out which tasks are in which task lists to build it all back together. It's doable. It's just a bit of effort. Then there was the Telegram application installed on there by default. It operates just as Telegram does on any other system, and it stores same data in the same format, again, as things like iOS and Android. Telegram does encrypt its files. It has its own format for its own files, so you would need a way to read that, to access that, to decrypt it in order to read those messages. But it's the same as Telegram on any other system. And last but not least, we have Wi-Fi connections. If you connect to a Wi-Fi hotspot, it gets its own NM connection file in system connections folder. It's named for the SSID, whatever that may be. So Starbucks.nm connection might be one if you go and connect to a Starbucks network. If you then forget the network, it deletes the file, but it's a simple delete. So it's not overwritten. It stays there. It's potentially recoverable using forensic tools for a period of time until the system decides to overwrite that data. So be aware, you can get a list of network connections the device has connected to. If it's remembered, that will be a file that exists in there. If it's been forgotten, potentially you can still recover all of that data. So lots of useful information in there. Caveat this with this is only an initial look, so there possibly is, well, there will be more data to find on these devices. And as I say, at the moment, I've only looked at Manjaro. So there are a list of other, I can bring up actually this is the list of software releases so far that are available for these Linux smartphones, these PinePhones. So you can use Ubuntu Touch is one I want to play with because Ubuntu really is the most popular distro of Linux. But you can use, say, Fedora, Mobian, OpenSUSE, Sailfish. All of these are options. I don't plan to test all of these because that would be a full-time job, but I do at least want to play with things like Ubuntu Touch and see if the artifacts are the same, see if they're stored in different locations. Could be completely different as far as I know up to this point, but at least we're kind of starting to get an understanding about the type of data that's stored, where it might be stored, and the format that that data is in, so that we know whether existing tools might be available to parse it, or whether we need to start thinking about writing our own tools to do this sort of thing as well. So yeah, if you're interested in more of this, pine64.org. So pine64.org is where you can purchase these things. There's a shop. This is, for example, the PinePhone page that shows you the specifications of the particular PinePhone that's available at this point in time. They release different versions. So the version that's available now, probably different to the versions that I've tested because they keep releasing new devices. And the newer one that I've purchased is much more stable than the previous one I purchased. So hopefully that will continue to be true and they will improve as they go on and more things are released. So this is what you can buy at this point in time. There's also a wiki. So I'll point you to the wiki, which is wiki.pine64.org. Lots of helpful information on the phone itself, the pins on the back, different software releases, how to upgrade the device, how to flash it with different versions of Linux if you want to put a different version on to the one that it comes with. So at the minute, I think they all come with Manjaro, but you can flash it to use a different version, what components they have, all of that sort of information. And it's also worth noting, it's not just PinePhones. So if I come back to here, the device list, they have laptops, they have single board computers like Raspberry Pi type things. There are tablets, there are smartwatches, soldering irons. There's lots of different devices that Pine64 do, all along a similar vein, trying to kind of bring up the market share for Linux devices and make them kind of more interesting, more mainstream, more available to people. So I really hope this kind of project does continue and takes off, because it's really exciting to have true Linux-based smartphones in addition to iOS and Android, have more options and have more access to the hardware and be able to develop and do more on these particular devices. So big interest for me, and I will continue to do more research into this. If anyone else has done research, definitely be interested to have a chat. So get in touch. My contact details, if you want to get in touch, I'm on LinkedIn, I'm on Twitter, probably more active on Twitter. So I'm Forensicator, which, yeah, that's what I do. So that's my Twitter handle. So yeah, feel free to reach out. And yeah, if anybody's got any questions, I will stop sharing and I will come back to questions.
Yeah. We have a few, so I can read it to you if you want. So the first one is, who manufactures this Linux-based phones? So if I understood well, it's Pine64, right?
Yeah, Pine64. Yeah, they're the only ones at the moment, as far as I know. This is the first device that is Linux, but yeah, all pine64.org is everything at the moment.
Okay. Then we have another question, which is, do you work with devices other than smartphones?
I do, yes. Yeah. So I say been in digital forensics for 13 years. Mostly laptops, desktops. I've done a few servers. Yeah, Windows, Mac, smartphones, iOS and Android primarily. Have looked at things like Blackberries and Windows phones in the past, which aren't so much a thing anymore, thankfully, really, to be honest. But yeah, also like the old Nokias and yeah, pretty much everything I've looked at some point. So yeah, definitely not just smartphones, just this is my current field of interest and my research project.
Okay. So we have few minutes left. So maybe one last question for me. I saw that there is some stuff in the chat. Okay, so there is a question in the chat actually. And the question is, how much difference is there with the Linux system in terms of forensics, artifacts, and structure?
Yeah, so only the phone-based stuff. So as I was kind of going through that list, basically every existing Linux artifact still exists, whether it's actually populated or not. So I mentioned the login log, so the WTMP log isn't really used anymore. The suspend log isn't, it's kind of inconsistently used, but the files are still there. So you will still find pretty much all of the Linux artifacts you would find on any Linux system, but you will then also have the phone stuff. So you've got like Telegram data because that's installed. You will have like call logs, SMS message logs, the calendar stuff, the task list, all of that is phone specific. So that's really the difference between the two. Well, two differences, I guess. One, it doesn't really populate the Linux, all of the Linux artifacts in the same way. And the second one is you have the extra phone-based stuff that you wouldn't find on a typical Linux system because typically Linux doesn't do phone stuff.
Okay. Cool. So thank you very much, Kathryn. I think we're just on time. So I think we will close this presentation, and it was the last presentation for the room 2. We have one very last presentation in the main room, which starts in 2 minutes. So I know invite you to go there to listen to our last presentation, which will be with Chelsea Slack. So Chelsea is deputy head of the cyber defense section at the international staff of NATO, of the NATO headquarters in Brussels. So I think it will be quite interesting. So I'm really looking forward to it and see you all there in the main stage. So bye everyone, and thank you very much for listening to Room 2 today.
Thank you very much.
Thank you.